So thank you, students. Today we will do a problem in the Pert topic. Okay, Pert, we know program evaluation and a review technique. That's what the problem given to us. Okay, right. So the problem is about this: draw the project network, critical path, project time, and the probability that the project can be completed in 4 weeks earlier. That's what we have to find here. Okay, that's what is given to us. First, project network, then critical path we have to draw, then project time means the time taken through critical path, and then probability that the project can be completed in 4 weeks earlier than expected. That's what we need to understand. Now let us analyze the problem here. There are activities 1 to 2, 1 to 3, 1 to 4, 2 to 5, 2 to 3 to 5, 4 to 6, and 5 to 6. These are the activities. Now the optimistic time for this activity is that take for example, you can take is a week, 1 week. For this activity 1 week, for this activity 2 weeks, for this activity 1 week, like that. Most likely time is that this normal time that the activities can be finished. That is 1 week for first activity, 4 weeks for second activities, like that. Last one is pessimistic time, meaning that we are thinking negatively about the event taking place. Therefore, that time is 7 weeks for the first activity, 7 weeks for the second activity, 8 weeks for the third activity, like that it goes. Okay, so now we have to draw a network for this problem. Then afterwards we have to find out the probabilities, then the critical path, project time, lastly the probabilities we have to calculate. Now let us start with the drawing the project network. Okay, project network, that is what we have to draw first. Now in this activity 1 2 3 4 5 6 are the events, we say, and the events are joined by the activities. Okay, so that's we know already. So first I am taking first event as this. Okay, then second activity I am taking like this, second activity, sorry, second event. Third event I am taking here, third event, right. Then fourth activity I am taking here, fourth activity. Okay, fourth activity. Then fifth activity I am taking here, fifth activity. And lastly I am taking a sixth activity here, sixth activity I'm taking here, like. Okay, right. Now look at the problem given. The first event is connected to the second event, so the first event is connected to the second event. First event is connected to the third event, first event is connected to the third event, and then first event is connected to fourth event, first event is connected to fourth event. Then 2 is connected to 5. Where is 2? Here 2. 2 is connected to 5. Then 3 is connected to 5. 3 is connected to 5. Activities. This activity is connecting fourth event and sixth event. This activity is connecting fourth event and fifth event. And then the last one, fifth, is connected to sixth event. Okay, so now we have got the network for the given problem. Okay, now I am dividing each event like this, two halves, because here I am going to write the forward time and here the backward time, or we can say this is the earliest time and here the latest time. So each and every event will have the earliest time, latest time, earliest time, latest time, earliest time, latest time, and the earliest time, latest time. But look at this, we have 3 time estimate here. Let me correct, for each and every activity, first activity, second activity, third activity, fourth activity, fifth, sixth, and seventh, we have 3 time estimate: optimistic time, most likely time, and pessimistic time. Okay, but what we need is that each activity should have only one time, then only we can calculate the earliest time and latest time. So to get the one time, we are using this particular formula. The formula is that the expected time for each activity: the first activity 1 to 2, second activity 1 to 3, third activity 1 to 4, that last one, last activity 5 to 6, is calculated by this particular formula. Okay, the formula says that expected time equals optimistic time plus 4 time pessimistic time, 4 time most likely time plus pessimistic time. Optimistic time plus 4 time most likely time plus pessimistic time divide by 6. Okay, optimistic time is available here, that is 1. 4 times pessimistic most likely time, 4 into 1 4, 1 plus 4 5, 5 plus pessimistic time 7. Okay, so you will get 12 by 6, 12 by 6. Okay, what you'll you'll get 2 here. Am I correct? No, let us change the color, then only I can write that, otherwise we don't understand that. So here you must understand that here the time estimate is 2. Similarly calculate that, you will get to here it is 4, it is 4, sorry, here it is 4, and then here you will get 3. Okay, 3 you will get here 3, then 1 you will get here if you apply that particular formula, then 6 you will get here, you will get 6 here, then afterwards you'll get 5 here, sorry, here you'll get 5, and last one you will get here is 7. If you apply the formula you'll get 7 here. Okay, and that's what you have to. Now let me erase those things because that would be confusing to us, so we have to erase them. Okay, so this is what the expected time. So we have done a good thing here is that the 3 time estimate is reduced to a single time estimate by using the formula that expected time is equal to optimistic time plus 4 times most likely time plus pessimistic time divided by 6. If you apply that, you will get for the first activity you will get 2 weeks, second activity will get 4 weeks, third activity will get 3 weeks, and next activity will get 1 week, then next activity you will get 6 weeks, then 5 weeks, last one is 7 weeks you will get. Okay, right, and then it is we have to write these only times here on the activities now. Okay, now 1 to 2, what is expected time? 2 weeks, so we are writing 2 here, 2 weeks, and then for the activity 1 to 3, okay, the expected time is 4 weeks, expected time are 4 weeks, am I correct? So 1 2 3 4 weeks, then 1 to 4 3 weeks, 1 to 4 3 weeks, 2 to 5 1 week, 2 to 5 1 week, 3 to 5 6 week, 3 to 5 6 weeks, 4 to 6, 5 weeks. 4 to 6, 4 to 6, 4 to 6. Am I correct? So it is not here. It is 4 to 6, I think so. Am I correct? We have made a mistake there. It is 4 to 6, not 3 to 6. It is 4 to 6. Am I correct? So coming back and taking the ink there, and you will get here. It is 4 to 6. 4 to 6. Okay, so 4 to 6, how much is 5 weeks? 5 weeks. Right, then 5 to 6, 7 weeks. 5 to 6, it is 7 weeks. Right, so this is what we call project network. Okay, project network, but we have to calculate the earliest time and the latest time also. Earliest time here, latest time here. Okay, so how to calculate that? First I am taking 0 here. So this activity takes 2 weeks. So 0 plus 2, the earliest time for this event is equal to 2. Okay. Similarly here, 0 time, this activity takes 4 weeks. 0 plus 4, 4 weeks. 0 plus 4, 4 weeks we have. And here is a 0 starting, and here it takes 3 weeks by this activity. Therefore 0 plus 3 is equal to 3. Okay, right. Similarly we have to calculate for earliest time for the other events also. But look at this here. There are 2 activities are ending here. Am I correct? So how many earliest time we will have? 2 earliest time we will have. Through this one earliest time, through this one earliest time we will have. Am I correct? So if you come this way, 2 plus 1, you will get 3 as the earliest time. If you come this way, 4 plus 6, 10 weeks at the earliest time you will have. Am I correct? Am I correct there? So among this, what we have to write is that maximum earliest time we have to write. That's very, very important. Here, through this way, we have 3 weeks. Through this way, we get 10 weeks. Okay, so which is the maximum time is equal to 10, because for this activity takes 3 weeks. 4 plus 6, you will get 10 weeks. So I say that the maximum time we have to write here as the earliest time for this particular event. Right, similarly here there are 2 activities ending here. Okay, so the forward pass will have 2 earliest time. Through this one earliest time will come there. Through this another earliest time will come here. Am I correct? So this is how much? I think it is 5, right? 5. So if you come this way, you'll get 10 plus 7, you'll get 17 as the earliest time. Whereas if you come this way, 3 plus 5, 8 you get. So 8 weeks, 17 weeks. I told you just before that the maximum time only we have to take. So the maximum time is 10 plus 7, 17. That 17 we have to write. So this is called forward path calculations or earliest time calculations we say. Okay, now we have to find out the latest time for each and every event here. First event, second event, third event, fourth event, fifth event, sixth event. We have to find the latest time. So what is the latest time of the sixth event? Is that this earliest time we have to write, that is 17. 17 is the earliest time for this particular event. Now we have to subtract and we have to write in the latest time places. We have to subtract and we have to write. That's called backward pause. We say backward pause there. So 17 minus 7 we will get 10. So 10 we will write here. Okay, 10. Now 17 minus 5 we will have here. How much we will have here? 17 minus 5 will get 12. Okay, Now look at this, there's a problem here. What is the problem is that we will get it is not the problem here, but we have the problem also. We now don't have the problem here. Let me correct. So 10 minus 1, 10 minus 1. So 10 minus 1 is equal to 9 weeks. That is what we have to write here. 9 weeks we have to write. Here 10 minus 6, 4 weeks we will have here. 10 minus 6, 4 weeks we will have here. And then so that's all the latest time for this event, fifth event, for the second event, for the third event, and the fourth event. We can calculate the earliest time very easily because the backward pass have only one activity. But look at this first event. Okay, in the first event what we have is that 3 activities are going back. I mean, you will get 3 latest time for this particular event, the first event. One is from here, the other one is from third event, and third from fourth event. So 3 latest time we'll get. Okay, so the 3 latest time we have to calculate first. Okay, right, 9 minus 2, we'll have 7 as the latest time through this particular path. This particular backward pass, 4 minus 4, we will have 0. Okay, we'll have 0. If you come backward pass from fourth event to first event, here we will have 12, here we have 3. So what we have, 12 minus 3, you will have 9. Okay, you will have 9 here. 12 minus 3, you will have 9, and here 4 minus 4, you will have 0, and 9 minus 2, you will have 7. You must note very seriously that when we come backwards, okay, when we come backwards in calculation of the latest time, we have to take only the small element. We should not take the big elements. Okay, we have to calculate all possible backward pass calculations. At the end we have to take only the small latest time. Okay, so that we have to write here. So 4 minus 4, you'll get 0. That 0 we have to write here. Okay, right. This is the way we can calculate what we call it as earliest time and latest time for each and every activities. For each and every activities, it is possible for us to calculate the earliest time and the latest time. Here the earliest time, latest time is 0, earliest time is 0. Here the latest time is 9 weeks, the earliest time is 2 weeks. Here the earliest time is 4 weeks, latest time is 4 weeks. Here earliest time is 3 weeks. Here latest time 4 weeks. Here earliest time is 10 weeks and latest time is 10 weeks. And here the sixth event, the earliest time is 17 weeks and latest time also 17 weeks. Thus we can calculate the earliest time and latest time for each and every events. Event number 1, event number 2, 3, 4, 5, 6. Okay. Then afterwards we have to see the earliest time and latest time. Earliest time and latest time, such that the earliest time, the difference between the earliest time and latest time must be equal to 0. Such a event we have to give importance. The difference between the earliest time and the latest time must be equal to 0. So such an event we have to find out. Okay, the difference between earliest time and the latest time must be equal to 0. Such an event we have to find out from the network. Now I am taking the first event where the earliest time is 0, the latest time is 0. So 0 minus 0, 0. Now I am taking the second event the earliest time is 2 and latest time is 9. So the difference is not equal to 0. Am I correct? Third event, the earliest time is 4 weeks, latest time is 4 weeks. The difference between them is 0. And in the fourth event, the earliest time is 3, latest time is 12. The difference is 9. Here the earliest time is 10, latest time is 10. The difference is 0. In this sixth event, the earliest time is 17 weeks and latest time is 17 weeks. The difference is 0. Right. Now, in which event the difference between earliest time and latest time equals 0, those events we have to take care of. We have to find out the events where the difference between earliest time and latest time must to be equal to 0. That's what we are interested. If you take into account, there are events in this particular problem. The first event, okay, look at the first event. Here the earliest time and latest time, the difference between earliest time and latest time equals 0. And here the second event, the difference is not 0. The third event, the earliest time, the difference between earliest time and latest time is 0. And in the fourth event, the difference between earliest time and latest time is not equal to 0. In the fifth event, the earliest time 10, latest time 10, difference is 0. Okay, so we have to give importance for these events where the difference between earliest time and latest time must be 0. So again, sixth event, the difference between earliest time and latest time equals 0. So note it. Right. Now through this we are drawing a path from 1 to 3, from 3 to 6, from 5 to 6. Okay, that is, we are drawing a path through which the event where the difference between the earliest time and latest time equals 0. I repeat, we are making a path such that the events difference between the earliest time and latest time equals 0. Okay, we are drawing a line through which the events where the earliest difference between the earliest time and latest time equals 0. Now look at this path and not this path, because the difference between the earliest time and latest time is not equal to 0 for this event. Here also the difference between earliest time and latest time not 0. Therefore through this particular event we are not drawing the path. Okay, so this path through which we are drawing such that the events which have the difference 0 between earliest time and latest time is called a critical path. Okay, so here the critical path is 1 to 3, 1 to 3. Okay, then 3 to 5, 3 to 5, and next one is 5 to 6. So this is called the critical path, we say. Okay, we can shortly say I am writing as critical path. So critical path is a path. Critical path is a path in which the events have the difference earliest time and latest time 0. Okay, right. Now add all the time taking through this critical path. Add all the time taking of the activities through this critical path, and that is called project time. Okay, so time taken through the critical path, TCP, we can say. Time taken through the critical path here is equal to 1 to 3. So from the event 1 to the event 3 we have 4 weeks. Right. From 3 to 5 From 3 to 5 here, the time taken by the activity is 6 weeks. So we are adding 6 plus. Then 5 to 6, how many weeks it takes? It takes 7 weeks. Am I correct? So 7 weeks. So total, how many weeks are there? 4 plus 6, 10. 10 plus 7, 17. So 17 weeks you suppose. Okay. The time is not given here. We have to give the timings, but it's not given. But in the problem, it is given as weeks. Therefore, we can say that 17 weeks. And this is what the project time. So we have, by this time, we have finished the answer for the first one, project network, we found out. Then critical path, we found out. And the project time. Yes, we finished the project time also. Here the project time is the critical time through the critical path, or time taken through the critical path is called the project time. So that project time also we have calculated, and critical path we have calculated, and the project network we have finished by now. Okay. Now the left out thing is that about the probability that the project can be completed in 4 weeks earlier. The project can be completed 4 weeks earlier. That's what. So here the project expected time of completion of this project takes 17 weeks. The expected time for finishing the project is 17 weeks. Okay, is 17 weeks of, or 17 weeks you can say, or 17 weeks. So to find out the answer for the last question, we have to find out the Z variate. Okay, normal variate Z we have to find out. So Z, we know that Z variate is nothing but it is targeted time, and we have to subtract that from the TCP, the time taken through critical path, and divide by sigma. Sigma means standard deviation. Okay, so this is what we have to calculate now. This we have calculated just before. The targeted time is the time that given in the problem. That is 4 weeks earlier. That's what it is expected. 4 weeks earlier. That means what here? It takes 17 weeks. 4 weeks earlier means what? 13. Am I correct? So our aim is to find out the targeted time is 13, because 4 weeks earlier. That's what they say, 4 weeks earlier. But the expected time is 17 weeks. So 4 weeks means what? 13 minus 17 divided by sigma. Sigma means what? Standard deviation. Standard deviation of the project network. Standard deviation. So standard deviation, we have to take standard deviation through this particular critical path only. Okay, right. So for that we have the formula here. Standard deviation we have to calculate here. Standard deviation for each and every activities by using this particular formula. This is a formula available. Standard deviation equals pessimistic time minus optimistic time divided by 6 whole square. Okay, pessimistic time minus optimistic time divided by 6 the whole square. That is standard deviation. So standard deviation for each and every activities. The first activity, for the second activity, for the third activity, for fourth, fifth, sixth, seventh, for all the activities we have to calculate standard deviation. Okay, so that's what the next step. Okay, right. In that standard deviation what are the standard deviation or variance coming in the critical path. I mean critical path, that only we have to take into account. We should not take the standard deviation or some of the standard deviation not non-critical path. We should not take into account those things there. Okay, right, let us calculate the standard deviation for the first activity. Pessimistic time 7 here, am I correct? Yes. Minus optimistic time 1. So what we'll have here, 7 minus 1, 7 minus 1, 6. Then 6 divided by 6, 1. 6 divided by 6, 1. Its whole square is equal to 1. Am I correct? So here actually we should have 1 here. Okay, right. Then similarly we have to calculate the second activities also. For the second activity, what is the pessimistic time? 7. 7 minus optimistic time 1. 7 minus 1, 6. Again 6 by 6, 6 by 6 here, 6 by 6, 1. 1 square is 1. So if you calculate that way for each and every activities, you will have here also you will have 1, here you will have 0, here you will have some 4, and here you will have 1, and here you will have 4. So 1, 1, 1, 0, 4, 1, 4. So these are the standard deviation of all the activities. Okay, so just before I told you that we have to give importance for the variance or standard deviation square for the activities which are in the critical path. Which is a critical path here? The critical path here is 1, 2, 3. So 1, 2, 3. So that only we have to take into account. 1, 2, 3, and then 3 to 6. So 3 to 6 is where? 3 to 5. 3 to 5 is how much? 4. Right. Then 5 to 6. 5 to 6, 4. Okay. Right. Now sigma square. Okay. Our variance, we can say sigma square is equal to only these we have to take into account. Okay. That is we have rounded, that is the variance on the critical path only we have to take into account. Okay, so we'll have 1 plus 4, 1 plus 4 plus 4, 1 plus 4 plus 4 will get 9. Okay, we'll get 9. So sigma square is equal to 9. Therefore, what is sigma? So sigma is equal to 9. So that's what we have to substitute here. So sigma is equal to 9. Sigma is equal to 9. And this is what we have to substitute here. This is what we have to substitute here. Okay. So if we substitute that, what we will be getting is that if we substitute this here, then Z is equal to Z equals 13 minus 17 divided by 3. This would be equal to minus 1.33. So this is what is it. Okay. So normal variate we have calculated, and that equals minus 1.33. Minus 1.33 is the normal variate. But we have to find the probability that this area exists in the normal curve. This area, which area? I am writing this here. Here I am writing. So the probability probability that, okay, probability that z variance lies between greater than or equal to z and greater than or equal to 1.33. Probability that z lies between 0 and 1.33. Okay, we know that this is a normal curve. In this normal curve, okay, the point 0 is here and 1.33 may be here. Okay, so 0 is greater than 3 and is greater than 1.33. What is that particular area we have to calculate in this normal curve? Okay, so that's what we are interested. Okay, so this particular area, that's what we are interested in. This is a particular area we are interested. Okay, right. And from the normal table, we will get this equals or this probability. Okay, to make it clear, this probability that z taking the value less than or equal to minus 1.33, that also we can. So we will get that if you see in the normal curve, we'll get the area for that particular area would be equal to 0.9082, or we can say that is 90%. Am I right? The probability is that 0.9082. That implies what? The probability is that the project can be finished 4 weeks earlier. Probability that probability that the project can be completed 4 weeks earlier is equal to some 91%. We can say 191% is the chance that the project can be finished 4 weeks earlier than the expected time of 7 weeks. Okay, so this is the method we can do any problem. Okay, so if the problem given like this, we have to do the problem like this. Okay, first we have to find the project network. For that, the numbers are the events. Then we have to join the events by the way it is given there. So that will give an activity. Each activity have the 3 times optimistic, most likely time and pessimistic time, and that 3 times we can change into a single time. The 3 times we can change into a single time by using this expected time formula. Okay, then after finding out a single time estimate, we are calculating the earliest time and latest time for each and every events here. After finding out the earliest time and latest time, we have to give importance for the events where the latest time and the earliest times are equal, or equally we can say that the difference between the earliest time and latest time equals 0. Such an event we have to take, and we have to make a path through that is called critical path. Then time we are adding, that is the time taken by the activities we are adding through the critical path, that is called time taken through the critical path, or we say it is a project time. To find the probability that the project can be finished within a targeted time, we need to calculate the normal variate z given by the formula T by TCP divided by sigma. That is the targeted time that they are expecting to calculate, and this is expected time comes from the critical path calculation, and then sigma is the variance through the critical path from the variance sigma square we can get a sigma, that is standard deviation. That is what we have to substitute here. We will get one value for the normal variate. For that normal variate we have to find out the region from the normal curve. Okay, and that normal curve area will give you the probability that the project can be finished in a particular targeted time. So this is the way we can finish any problem in a Pert problem. Okay, so thank you very much for listening to me for the past nearly half an hour. Okay, and thank you very much, and I will come with another problem with another video. Okay, so thank you very much. Thank you.